In this lesson, we're going to talk about how to simplify fractions. When we simplify fractions, it is very similar to the equivalent fractions we were just talking about. So we're going to take a value, a fraction that is not reduced, and we're going to simplify it hopefully down to lowest terms, meaning that once we're done, there are no common factors other than 1 between the numerator and the denominator. So one method in doing this is just to continue to divide the top and the bottom by the same number until you arrive at your lowest terms. So notice my original fraction is 48 over 96, and I know that they're both even, and so I've chosen to divide by 2. And when I divided by 2, that gave me 12 over 24. And those are still both even, so I've chosen to divide by 2 again, which gave me 6 over 12. And those are still both even, so I chose to divide by 2 again, and that gave me 3 over 6, and I noticed that 3 went into both of those values, so I divided by 3, and my simplest terms are 1/2. So that's one method, is just to keep dividing until you get down to the end, basically, until you cannot divide the top and bottom by anything else other than 1. Another method is using prime factorization. So we talked about how to do this. Remember, you started with your number and then you break it into a factor tree. So for instance, this would be 4 times 12. 4 is 2 times 2. 12 is 3 times 4. And 4 is 2 times 2. And so I would write that as 2 times 2 times 2 times 2 times 3. If I repeat the process for 96, I'll save you the time. I've already done it. 2 times 2 times 2 times 2 times 2 times 3. Now what I'm going to do is I'm going to cancel any common factors. So I can cancel 1 pair of 2's, and 2 pair of 2's, and 3 pair of 2's, and 4 pair of 2's, and a pair of 3's. Now on the top, everything has gone away, but I don't want to write that as 0, because if I took 3 divided by 3, I would get 1. So really there's just a 1 left over on the top. On the denominator, everything has canceled except for this 1, 2 that's all by itself, and so my result is 1/2. So the first way was to continue to divide by a common factor on top and on bottom until we have simplest terms. Our second way is to do our prime factorization, which also resulted in 1/2. And our last way is to find the GCF, and again, we already talked about how to break this into our factor trees to find the prime factorization of each of our numbers, which I did very quickly on the last page. Again, I would do this here. I'm going to save us the work. If I did the factor tree, here's my 2 factor trees, essentially my prime factorizations. And so I can find the GCF, which is the greatest common factor, and then divide the top and bottom by the greatest common factor. The method for finding the greatest common factor is to essentially list both prime factorizations, and then I'm looking for anything that they have in common. So I'm looking for pairs. So I have a pair of 2's, a pair of 2's, a pair of 2's, a pair of 2's, and a pair of 3's. So every pair, notice I wrote that value 1 time. So I had 4 pairs of 2's, so I wrote 4 2's. I had 1 pair of 3's, so I wrote 1 3. If I multiply all of those, I get 48. What that tells me is that 48 will go into both 48 and 96. So notice 48 over 96, if I divide the numerator by 48 and the denominator by 48, I end up at my correct answer of 1/2 again. So really that's 3 different ways to go about doing this. You should choose the way that makes the most sense to you. There's really no one best way to do it. The best way is the way that makes sense to you. So here are 3 we're going to try together. Again, 10 over 30. If you want to write this as a prime factorization, 10 would be 2 times 5. 30 would be 2 times 3 times 5. Again, I'm just not writing out the tree, but that's essentially how I found it. So I'm going to divide the top and bottom by 2 and the top and bottom by 5. Nothing left on the top except for 1. My denominator, I get a 3. This one is negative, so be very careful on the negatives. A lot of times once we get done with all the factorization and everything, we forget about the negative. So not a bad idea to circle it or something to remind you that that answer should be negative when we get finished. Again, I could break this down into 115. 5 goes into 115 23 times, it looks like. And those are both prime. And so that I'm going to write 5 times 23. I'm going to keep this negative out front. 25 obviously is 5 times 5. One pair of 5s will cancel, and that gives me 23 on top and 5 on the bottom, and my answer is negative, and so I keep it negative. We'll keep it improper for now. We'll get into improper fractions later on. Last one, 170 over 102. This one might be one where you would just continue to divide by 2. So if I divided by 2 on top and bottom, this one would give me 85, and this one would give me 51. And I can see clearly that 2 is not going to go into those any longer. If I try to divide by 3, that's not going to work. This one actually is going to be kind of tricky because the next number that will go into these, and this would just be a trial and error using your calculator, is 17. So if I divided the top by 17, and again, this could be one where I break it down into factors, 5 and 17, both prime. 51 is 3 and 17, both prime, and that's going to leave me with, if I had 5 times 17 and 3 times 17, and I divide them both by 17, I get my result of 5/3. Here are 3 for you to try on your own. So press pause, do all 3, then press play to see how you did. For my first, again, if you're finding the GCF, I know that 15 would go into the top and onto the bottom. So I would divide the top and bottom by 15, and that would give me 2/3. If you need help finding that 15, remember all I'm doing is making a factor tree. 3 times 10, 10 is 2 times 5. So 30 would be 2 times 3 times 5. And 45 would be 5 times 9, which is 3 times 3. So 3 times 3 times 5, and anything that has a matching pair is going to become part of our GCF, which would be 3 times 5 or 15. So any of the methods that we talked about are just fine to use here. Either way, no matter what, you get 2/3. For question B, again, this one is a negative, so not a bad idea to circle it so you remember that it's negative. For this one, I'm actually going to divide by 11 on top and on bottom, and that gives me 1/3, and again, my answer is negative. And for my last one, again, not a bad idea to make a factor tree. This one, well, I would probably do 3 and 25, and then 25 is 5 and 5. For 105, if I make a factor tree, obviously 5 goes into it because it ends in a 5, and that would be 21. And 21 is 3 times 7. And so this is 3 times 5 times 7. My 3's cancel, my 5's cancel, and that gives me 5/7.